what we have seen in the last lecture. We have given the integration x is equal to a to x is equal to b, y is equal to c, to y is equal to d, f of x y dy dx. Or we have given integration y is equal to c to y is equal to d, x is equal to a, 2x is equal to b, f of x y dx dy. So if you observed both the integrals, the limits of x from a to b, the limit of y from c to d, both the limits are constant. What does it mean? Whatever the surface we have given z equal to f of x y, our region is only the rectangular, right? See, here this is the line, y is equal to c, y is equal to d, and the line x is equal to a to x is equal to b. So our region is a rectangular region, and over that rectangular region we have given the surface z is equal to f of xy. But in place of this rectangle, suppose you have given any general region. For example, say this is the region we have given, right, over xy plane. So this is y-axis, this is x-axis. Now the question is, suppose you have given the surface z is equal to xy bounded by this particular region R. This is our region R. Then how do we find the volume? So in today's video, we shall discuss whenever we have given any region R, then first how do we write the limits and then how do we integrate. But we again divide the session into two parts. We have given the limits and then we integrate, and in the second part we write the limits and then we integrate. So let us start the example. Whenever we have given the limits, whenever we want to write the limit, that we shall discuss. That suppose we have given any given region, general region R, then how do we write the limits, right? So our first example is evaluate integration 0 to pi, integration 0 to x sine y dy dx. What we have seen in the last video, both the limits were constant, so we were concentrating on dy and dx, or dx dy. We find the corresponding limit of x, limit of y, and then we integrate. Here 0 to pi, 0 to x sine y dy dx, which is equal to, again, what is the first inner integral is with respect to y, outer integral with respect to x. So inner limit is of y. So first I write, this is integration y is equal to 0 to y is equal to x. Then outer limit is of x. Clear? So I write integration x is equal to 0 to x is equal to pi x sine y dy dx. You have to be sure about this, that first observe which are the limits of x, which are the limits of y. Keep in mind, outer limit is always constant. So this is equal to, now we integrate this quantity with respect to y first. So what is the quantity? X sine y. Integration x equal to 0 to x equal to pi we are integrating with respect to y. So x is assumed as constant. The integration of sine y, what is the integration of sine y? Is minus cos y. With the limit of y, lower limit is 0, upper limit is y equal to x, and dx as it is. So in place of y, we substitute the upper limit minus y is cos x, so this is minus cos x. This minus sign is for lower limit. Don't make any mistake. When y equal to 0, this is cos 0 with minus sign. So this is cos 0 with minus sign and dx. So this is equal to integration x is equal to 0 to x is equal to pi minus x cos x minus plus cos 0 is 1. So 1 into x is x dx. Right. So this is nothing but integration x is equal to 0 to x is equal to pi, and taking x. Okay. So how do we integrate this quantity? This minus sign, let us keep it outside. This is x cos x dx and plus integration x is equal to 0 to pi x dx. Now here the second integral x dx, you know how to integrate it. This is very simple. The only integration of x is x square by 2. But how do you integrate x cos x? We have to apply UV rule. What is UV rule? Integration u into v is equal to u integration of v minus derivative of u integration of v and whole integration, right? But you know the general rule of integration by parts also. So what is the general rule of integration by parts? I am writing integration as the suffix. This is the integration of v minus I am writing prefix for the derivative. So u dash, again integration of v1 plus u2 v3 minus third derivative of u, fourth integration of v, and so on. You know, this is the general rule of integration by parts, right? Now let us say x as u and cos x as v. So say this is u, this is v, then what is the integration here? This is equal to, this is minus sign, u as it is, as mentioned here, u as it is, integration of v. So I integrate cos x. What is the integration of cos x? Sin x. Then this minus sign, derivative of u, and then integration of this. So I have to differentiate this and integrate this quantity again, right? So the derivative of x is 1, integration of sin x is minus cos x. We repeat this process, we again differentiate this quantity and we integrate this quantity. But why do we differentiate this 1? It becomes 0. So 0 into anything is 0. So we just stop here. Over the limit x is equal to 0 to x is equal to pi. So this is the integration of only x cos x. Now the second part is what? X. So plus the integration of x is x square by 2 from x is equal to 0 to x is equal to pi. Let us substitute the limits. this minus sign, x is equal to pi into sine pi, minus minus plus, this is cos pi. Keep in mind, whenever we substitute lower limit, I always start with minus sign and the bracket. In this bracket quantity, I always substitute the lower limit. When x is equal to 0, 0 into sine 0, which is 0, plus 1 into cos 0. So this is cos 0. For the second integral, 1 upon 2 is the constant. When x is equal to pi, this is pi square. Minus sign for lower limit. When x is equal to 0, then 0 square is 0. So this is equal to, what is sine pi? Sine pi is 0. Cos pi is minus 1. So this minus sign, cos pi is minus 1. Cos 0 is 1. With this sign, it is minus 1 plus pi square upon 2. And what is the left hand side? Left hand side is this integral, which is equal to, so this is minus minus plus 2 plus pi square upon 2. This is the integration. Again I repeat, what is the first task of our example? Left hand side equal to, whenever I write the right hand side, make sure I must write which are the limits of y, which are the limits of x. Let us go for the next example. Integration over 1 to ln 8, integration 0 to ln y, e raised to x plus y dx dy. What is the solution? The left hand side, integration 1 to ln 8, 0 to ln y, e raised to x plus y dx dy equal to, what I do? As discussed, first I write the limit of x, then I write limit of y. Here inner is x, so the inner limit is of x, outer is y, so outer limit of y. As you observed, outer limit always constant. So this is equal to integration y is equal to 1 to y is equal to ln 8, integration x is equal to 0 to x is equal to ln y, e raised to x plus y dx dy. So first we integrate this quantity with respect to x. Which quantity? E raised to x plus y. How do we write e raised to x plus y? E raised to x plus y is equal to e raised to x into e raised to y, right? So this is equal to integration y is equal to 1 to y is equal to ln 8, integration x is equal to 0 to x is equal to ln y, e raised to x into e raised to y dx. First I integrate with respect to x and then I integrate with respect to y, right? So first integration of this quantity with respect to x. Whenever we integrate with respect to x, we assumed y is constant. So when y is constant, e raised to y is also constant. So e raised to y is constant. What is the integration of e raised to x? Is only e raised to x with the limit x is equal to 0 to x equal to ln y and then dy. Then what is this? This is equal to integration y is equal to 1 to y is equal to ln 8 e raised to y as it is. What is x? Upper limit is ln y. So this is e raised to ln y minus sign for lower limit. x equal to 0, so this is e raised to 0 dy. Now you know what is the formula for e raised to ln x. E raised to ln x is x. You know this, right? So this is equal to integration y equal to 1 to y equal to ln 8 e raised to y as it is. E raised to ln y is y. So this is y e raised to y, because e raised to ln y is y. So this is y into e raised to y. Right. This minus sign, e raised to 0 is 1. So this is 1 into this. So 1 into e raised to y is e raised to y dy. Clear? Okay. So now you know how to integrate this. Integration y is equal to 1 to y is equal to ln 8. Suppose I take e raised to y common, then this is y minus 1 dy. Now this is my u and this is our v. What is the general rule of integration by parts? Integration uv is u integration of v. So this is equal to u as it is. Integration of e raised to y is e raised to y. Right. See, observe this rule. I have already written here. Integration uv is equal to. So I have two quantities, u and v. U integration of v. Now we are working with these two brackets only. Derivative, integration, derivative, integration, derivative, integration. Right. See. U integration of v, derivative of u, integration, again derivative, integration, derivative, integration. Then alternate sign, minus, plus, minus, plus, right. So uv, derivative integration, derivative integration, derivative integration, and the alternative plus, minus sign. In Fourier series, actually we are doing this in detail, right? So what is the derivative of y minus 1? Is 1. Again the integration is e raised to y. Now the derivative of 1 is 0. So we stop here. Alternate plus minus sign. So here we have minus sign from y is equal to 1 to y is equal to ln 8. Hope this is clear now. Let us substitute upper limit first. Y is ln 8 minus 1 e raised to ln 8 minus 1 into e raised to ln 8. This is when y is equal to ln 8. Minus sign for lower limit. As I told you repeatedly, whenever I substitute lower limit, first I write minus sign, then everything I written in the bracket. So when y equal to 1, 1 minus 1 is 0. So this is 0. Minus sign. Y is 1. So this is e raised to 1. And therefore, this is equal to ln 8 minus 1 into e raised to ln 8 is what? That you know. That is 8 now. Minus 8. This is minus plus. E raised to 1 is e. So this is equal to 8 ln 8. This is minus 8, which is minus 16 plus e. This is the answer. Right. Again I repeat what we have given. Integration 1 to ln 8, integration 0 to ln y. What I have to observe? Which are the limits of x, which are the limits of y. Let us discuss one more example. integration 0 to pi, integration 0 to x, sin x upon x, dy dx. How do we start? The left hand side 0 to pi, 0 to x, sin x upon x, dy dx is equal to, what we have written? 0 to pi, 0 to x. Now I have to write which are the limits of x, which are the limits of y. Dy dx, so inner limit of y, outer limit of x. So this is equal to inner limit of y is equal to 0, to y is equal to x, outer limit of x is equal to 0, 2 pi sin x upon x, dy dx. So this is equal to integration x is equal to 0 to x is equal to pi. First I have to integrate with respect to y. What does it mean? The quantity sin x upon x is constant. What remained? Only 1. What is the integration of 1 with respect to y? Which is y. So this is sin x upon x into y with the limit y is equal to 0 to y is equal to x and dx. This must be clear to everyone. We are integrating with respect to y, so x is constant. So sin x upon x is constant, right? So this is equal to integration x is equal to 0 to x is equal to pi sin x upon x. Substitute the limit of y, upper limit is x, lower limit is 0 dx. So now can I cancel out here x and x? Then the remaining quantity is only sin x. So this is equal to x equal to 0 to x equal to pi sin x dx. This is very easy integration now. What is the integration of sin x? This is minus cos x from x equal to 0 to x equal to pi. This minus sign is common. Now should I write direct? This is repeated. Cos pi is minus 1, cos 0 is 1. You know cos pi is minus 1, minus sign for lower limit, cos 0 is 1. And so this is equal to 2. See, the integration, double integration, 0 to pi, 0 to x, sin x upon x, dy by dx is very much important integral, and in other videos we are also going to discuss this integral. So this is important, right? Okay, I hope this is clear. Now I am writing 2 more examples here. Integration over 1 to 4, 0 to under root x, 3 upon 2, e raised to y upon root x, dy dx. This is the first exercise, and the second exercise is integration 1 to 4, integration 2x square, 2 3x square, x into e raised to x square plus y dy dx. These two are in homework. Don't forget to mention the answer of these 2 exercises in the comment. In the next video, what we are going to see? Suppose we have given any general region R, then how do we write limit first and then integral? Thank you.